Welcome to this video on ray diagrams for diverging mirrors, sometimes called convex mirrors. Now, keep in mind here that real space is over here. In other words, the shiny side of the mirror is on the flexed out side, and this gray is to represent that paint that you'd have on the back side of the mirror. So this we'd call the virtual space, and this the real space. Now we're going to see that kind of the same ideas are true here as they were for the diverging lens. So I'm going to place an object over here, and notice there's no F or C point on this side of the mirror because this is no curvature on this side. So what we're going to do now is take this object and see what happens following the same rules that we had before. So let me switch here to my green, which I'm using to do my incident ray. And remember, that goes in parallel to the principal axis. It hits the mirror, and now it's going to diverge away instead of converge. So instead of converging through the focal point on this side, it's going to diverge away from what would line up from this focal point over here. So we'll go ahead and we'll draw that in. Now keep in mind, this portion over here is just a guide so that I can show the actual direction that this light ray will diverge. Again, we're going to go in now towards this focal point. Of course, that is not going to actually pass through the mirror, right? So what I'm going to do is actually erase this portion, because remember, that portion is not actually present, okay? It's just to help guide us so that we can go in towards that focal point. Now the actual light that hits the mirror will reflect, and it will reflect parallel to the principal axis like we had before. Now again, if I'm looking at this, I'm not going to be able to see a real image form. There are no actual light rays intersecting. So what's going to have to happen, just like we had before, is we're going to trace back the reflected rays. So here would be this first one over here, and then I will also trace back this reflected ray. And I see that the lines intersect at this point right here, which is the corresponding point to that point. So then I can assume that all other points along here would correspond below and hit the axis right there. So my image is formed much in the same way that it did for a diverging lens, and that was a smaller image that was upright or same orientation to the object over here, but it was a virtual image. It formed in the virtual space, which for a mirror is behind or in the mirror, because it's a place where actual light rays are just being traced back to. You wouldn't actually be able to project this image. So my eye would have to be somewhere along these points in order to actually see that image. But if you've ever looked at these diverging, or what are known again as convex mirrors, these are those mirrors that you use often to see around corners or to get a wider field of view, because what they're able to do is take a larger object or larger scene and reduce it so that you can see a lot more within the view. These are also on your car. So your passing mirrors will oftentimes say objects are closer than they appear. Our perspective tells us that if an object looks smaller, it's further away from us. And so obviously if the object looks smaller, we assume it's further away. Whereas when we're looking into a diverging mirror such as this, the image, which is appearing to be smaller, is actually deceptive because the object is larger than it appears. And so we must think, okay, it's not further away because it's smaller. It's just because I have a kind of mirror that's going to allow me to see a wider field of view rather than a smaller field of view. So always be careful when you're looking through your side mirrors on your car.